Hi, and welcome back. And today it's going to be a very old teardown phase, okay, of a multimeter, okay, because we've been having a bit of a clear out, getting rid of some of the old crap, okay, out of various labs around the building, and I come across recognise this? An old AVO 8, okay. Now this one's seen better days. So when it got chucked in the bin, okay, it actually got busted, okay, and it's falling apart, and I thought, hell, why not strip it apart, what's left of it, and yeah, we'll see what's inside, and have a trip back in time to see how multimeters used to work. And these ones are really, I mean, the AVOs were solid as a rock, okay. They went on for years, all the way through to the 90s, from when they were first done, what we call Mark Zeros, all the way, well, just, you know, Mark 1, all the way up to Mark 6s and beyond. Yeah, they're the old analog ones, and they were really precise, and they went on for years and years and years. And these AVOs used to be more accurate than some of the digital multimeters that were out at the time, especially ones that were just released. So I thought to myself, well, let's take it apart. So don't really have to do much with this one because its case is all cracked anyway. And yeah, basically all analog, no digital, okay. Bulky as hell, okay, and yeah, all that it's just basic passive components, okay. There's no amplifiers, there's no transistors, anything like that, okay. Just resistors, few inductors, yeah, that's about it. Battery, and the meter is basically is a galvanometer, okay. It's just a moving needle in, and the needle moves within a magnetic field, okay. It's basically a horseshoe magnet or something like that, and it'll have a, you know, your wire's going to a little coil, and when current passes through your wire in the magnetic field, you know, it deflects when the needle moves. Simple, okay. This technology was donkey's years old and it hadn't changed, okay. It only really started changing, only really started going over the digital multimeters in the became widespread in the 70s and 80s, okay. These, beyond that, okay, even in my day, you know, my younger days back in the 80s, okay, these were king, okay. You had an AVO 8, you was getting somewhere, and they were expensive as shit. No, shit's cheap, because shit is shit, okay. It expended more bloody gold. Yeah. Well, alright, anyway, what we got? Well, let's break it open, find out. So, like I said, this one's already busted up, okay, as you can see, because it was thrown in the bin. So, let's see if we can get the top off it. Yep, easy, just pull out, and there we have it. Okay, as I said, there's no transistor technology or anything like that. A few cores, few inductors, and yes, a hell of a lot of wire and chunky resistors in there. Okay, now bit the case in the bottom. And so what have we got on the front? Well, what it can measure? It can measure, you know, DC, AC, voltage, amps, resistance. Okay, just the basic. Back then, that's all that you wanted. That's all that you really needed. 4 terminals at the front. Okay, why? And why are they big clunky switches? Because they're all going to your shunts. Okay. You wanted to measure up here, you know, 2,500 volts, you'd shunt that down using resistors, you know, potential dividers, just to get it down to a lower voltage that you can really easily work with, just to get that needle deflecting, okay. It's all that it is, okay. It's just ratios, just resistor ratios, just to drop the ranges. That's all that it is. Okay, so for the big ones, okay, we've got these big metal spikes here, going back to these So these little levers, this is, I believe, the Mark II version, but from the Mark 1 to the Mark II, bloody hell, it's falling apart in your hands. Okay, there wasn't really that much difference. Okay, case, this is just a Bakelite case. Okay, plastic was modern, you know, when these were being made, and Bakelite was still out there. Okay, so this is, you know, when this breaks, it just breaks into chunks. Okay, none of this deformed plastic on these. You can bend these about. Okay, if you try and bend this, you break it instantly. So yeah. Anyway, up here, these pins, these are connected to our terminals at the front, 2500 volt terminals. These go back to these chunky wire wound resistors, if you can see them in here. Okay, just at the bottom. Okay, so you've got, I don't know, what are these? These are obviously wire wound, 14 meg. Bloody hell. Woohoo, little hiccup there. Oh, coughing my head off. Bloody dust and bits all in this thing. Anyway, back again after getting interrupted there. That was Peter, okay, someone who I work with. Anyway, back with this, yeah. So we've got some DC shunts in here. We've got 14 meg, two 14.7 meg, 2% tolerance, made by Whirlwind. Okay, made in England, just like this, made in England. Everything, all these components are made in England. Okay, actually, come to think of it, somewhere I've found some of those Whirlwind ones. I'll show you them at the end. I used to get the old resistors. Anyways, yeah, so there you shunt, so you drop your voltage across your resistors, just a potential divider. These will all go back to your other probes further down. Okay, huge big chunky ones for your voltages. Okay, nothing small about these boys. Yeah, so in the centre here, this is where all your galvanometer is, your to deflection needle. So we've got our magnet in here, if you can see it, and you see you've got a moving coil just in the centre there. What, and the needle that gets deflected, that you can see back here on the meter. Tap that, you can just see that swinging slightly, maybe. Okay. And one of the problems with these was always setting 0, okay, because your needle would hardly ever go to 0, okay, especially when you connect it in circuit. You have to balance your bridge and what have you. And over here we've got 0 in ohms, 0 in hundreds of ohms, whatever over here. 0 divided by 100, okay, to get the accuracy to try and get our needle to 0, and all that is all done all back here using these pots here. Okay, so we've got huge pots back here, if you can see these in here. We've got one in here, just here, one here. Like I said, this is our little horseshoe just here, magnet, north and south poles. Yeah, it's like bloody hell, man. This thing takes me back. And so what else have we got? We've got our current ranges, okay? Down here we've got our switches, big chunky Bakelite switches, you know. They're really built to last, these were. Okay. One of these would last, I don't know, they're built to last a lifetime. If this one hadn't gone in the bin, it hadn't been smashed, it would still be perfectly usable today. And yeah. So just when you measure current, you want your low resistance shunt, your low resistance shunts, okay, just points of an ohm or a few ohms or something like that. As you go up the amperage, you have to up your power and whatever across those shunts and everything. And down here, you can see them all here at the bottom. Okay, all these wires all going off to your switches at the front. Okay, and all these shunts back here. Look at that. All of this is just wire wound around the actual board. No PCBs you can see in there. Everything onto this plastic Bakelite stuff, okay? And soldered up with wires. Not a PCB in sight. It's quite amazing what you could actually do with. It's quite amazing what you can do with just analog components, okay? Just these resistive components, okay? You can actually measure voltages, currents, resistances, okay? A little bit of, you know, just basic physics, okay, and basic electronics. You know, all this is all built around Ohm's law, essentially. Okay, that's the only thing that this. And here, down here, this is our cut out our trip. Okay, plunger in. Okay, closes our contacts. You can measure a current. Brilliant. Anything gets too hot, this all. You know, you start drawing too much current or anything like this, or you get shorts, okay, you just trip out on this, okay, and it would pop out. You just pop out, all mechanical driven. None of this, no, you know, comparative circuits or overload protection or anything like this. It was all mechanical back then. It's amazing how far we've actually come from this, okay. So yeah. So that's it, you know. That's what there is in these things. Bloody amazing what they could do for the technology that was inside. And like I say, if this wasn't broken, it would still be usable today. And yeah, and tell you, bloody hell, man, check this out. You know, old style batteries. You'll never find a battery to fit in there. Never in your life, not now. If you wanted to run this, you'd have to do some modifications. Bloody hell, man. Not only that, you would never lose the instructions. Check that out. Okay, there it is. Universal AVO Model 8. It's an AVO 8. Okay, it doesn't say it's a Mark II, but you can tell. I can tell it's a Mark II by the looking at the front, because I have in actual fact got a Mark I buried somewhere. That never gets used anymore. I just keep it just because it's interesting. And on the back, look at that instruction manual on how to actually use your AVO 8. Okay, working instructions, important. Okay, brilliant thing. Made in England, made to last. Not like today's stuff, you know, break in a second. This is back in the days when we used to make things to last. Lovely. Anyway, that's that thing. And yeah, compared to modern day one, you know, look at that. Look at the size. Bloody hell. This thing can do more than this thing now. It's just as good. And yeah, compare it. Just pull this thing apart, just see what's inside it. So just do a compare. Just pull that one out so you can actually see it there. Yeah. Ah, it takes me back, that does. And it's like when you was measuring on this, you really had to pay attention to what setting you was actually on, what ratio. So you had all these shunts in here. This would actually affect what your circuit, you know. It's not like these where you know, 10, 20 meg, probably 10 meg, you know, terminals or something like that. Depending on what ratio on, you get different impedances. So for your meter, so you really had to pay attention about what scale you're on, because the accuracy really did vary quite a bit. To make sure, you had to really pay attention. It really taught you how to use the equipment back then. You had to pay attention to what you was doing. It's no slap it in, do a quick read and that's it. You had to really make sure what settings you was on and double check everything. Anyway, taking apart this fluke, let's have a look inside, see how it matches up. Yeah, I can't get this one out. Come on, come out of there. There we go. Should be using a crosshead, but someone's run off with tons of my crossheads. I've only got bloody big chunky ones left. Kill the person who keeps on nicking my bloody screwdrivers. Anyway, off the back comes. Immediately you can see in here, Okay, here we are, look at that big chunky fuse there, that's for our 10 amp range. Okay, down here R3, I imagine that's our current shunt. And what you're not, underneath here you got your display, that'll be the display driver, battery terminals and what have you. Buzzer at the top, you never used to get a buzzer on these, you had to pay attention to what you was looking at. Okay, no continuity testing with a nice pretty buzzer to tell you if it was you had continuity or not. You had to pay attention to what you was actually reading. Anyway, let's continue stripping this back. Let's see what's on the opposite side. Let's get rid of all these screws back here. Okay. Yeah. Let's see what we got. Is this gonna? Oh no, we've got some more here holding the ball. And what am I on? Of course, there's more bloody screws than those ones holding the terminals on. Oh, I must be losing it. But if ever you had to dismantle an AVO 8, you'd be in a world of pain. Trying to get to some of these components in here is next to impossible. You have to be a genius to disassemble one of those without breaking something. And it wasn't all on one board, you know, you had multiple boards on this. Multiple boards, multiple connections. Various things all screwed together in a convoluted manner that only a complete mad scientist would know how to disassemble. Okay. So off we come. Here we go. Off the back. You know, look at all that digital on there at the top. You know, we've got what have we got on? Yeah, can we pull this out now? Come on. Oh no, of course we can't pull it out because we've still got the my little rotary selector here. Can we get this out? Will it let me pop this out? I don't think it will. It's on Thomas. Come on. Out it comes. It won't let me take it out. Let's see if it will come out from the bottom. Come on, you're not going to defeat me getting this out. Yeah, it doesn't want to come out of here. These clips are well in for this switch. Come on. No, it doesn't want to come out. This circuit board, it just doesn't want to budge without taking that or am I a complete knob end? Let's see. Oh, I'm missing something here. It doesn't want to come out. Cool, blimey. This is one thing about flukes. When they make something, they definitely don't want you taking it apart. There we go, right then. Get there in the end. Dave Jones will be laughing his bloody head off, me taking it apart a multimeter and not being able to work this out. Bloody hell. There we go, on the front. Our rotary switch, okay. No clicky dial. Okay, this is actually one track, switching in and out, different switches. You can actually see the contacts there. Okay, there'll be a metal contact. Yeah, it's a spring contact underneath. Okay, making connection to these gold-plated connectors here on the opposite side. That's basically it. Okay, screen is well and truly fixed in place there. Let's see if we can pop this off. Yeah, off it comes. There we have it. Okay, one multimeter, the LCD screen there. Polarizer in this. Okay, that's the chip that does all the work. Okay, so what have we got? Oh, a bit more off. It's a M430F448. Yeah, that's our microcontroller. Does all the brains, everything. Yeah, that's all that it is. Simple. There's nothing particularly special in here. MCU, buzzers, bit of memory, battery. You got some protection in here, thermal protection. You got over voltage protection, current protection. You got your current shunt. Yeah, backlight just there, LED. Our backlight on the display. Yeah. So all of that is basically that and a bit more, old and new. Well, let's put this back together before I forget how it goes together. And yeah, that's it. Nice quickie one. Old technology, new technology. Have I got those old resistors again? No, I did have a packet of old what are those? The Waywin resistors, actually wire wound, really black and dusty in colour, and the actual values were hand painted on, unlike these ones. Okay, you can see these. Okay, nice, clearly printed. The ones that I found are actually hand written. That's how old they were. They came in a paper envelope, and yeah, if I can dig them out, I will show you in one of the videos. Anyway, I'm going to busy myself getting this multimeter back together, and I'll see you next time.